our evening seminar on an absolutely critical subject, which is taxing energy use. So anybody who has anything to do with energy or environmental policy, climate change, will know that this is one of the most important subjects on the agenda. We're extraordinarily lucky to have Michelle Harding talking to us. She comes to us, as you can see, from the OECD, the Organization for Economic Cooperation and Development, which has been a shining light for many years in terms of doing analysis on energy and environment taxation. And those of us who've worked academically in that area find ourselves with a very thick pile of books on the subject, dating all the way back to the early 1990s, when very few people were really thinking about this in any detail. Michelle comes from the tax part of the OECD rather than the environment part of the OECD, which is the part that I've interacted with on environmental taxation. So it's going to be very interesting to see that kind of difference there, though she tells me she works closely with colleagues in the Environment Department. She's both a lawyer and an economist, and comes from New Zealand, where she did a joint degree in those two subjects, is a qualified barrister, as well as having worked for the New Zealand government and the Treasury for some years before coming across to the OECD. So, very welcome. Thank you very much for coming. Much looking forward to hear what you have to say. And the format of the evening, for your benefit as much as anybody else, is if you'd like to talk until 20 past, something like that. We'll then have some questions and discussion, and then when we feel we've had enough, we will go next door and have some refreshments.
Great.
So, welcome.
Great. Thank you. Thank you. Good evening, everybody, and thank you to the UCL-Energy Institute for hosting this seminar. I'm going to present the findings of a 2013 OECD publication called Taxing Energy Use, a Graphical Analysis, which provides the first systematic comparative analysis of energy taxes across all energy use, both within OECD countries and across OECD countries. To start with some context, why look at energy? Energy is obviously fairly important to modern economies, both in industrial production but also in household living standards. It's a key item in consumer budgets and contributes to heating and transport. But at the same time, it has significant environmental impacts. It's responsible for roughly 70% of man-made carbon emissions across the OECD, and it's also a significant source of local air pollutants. Energy taxation is important. It's one of the major tools available to governments to influence the patterns of energy use and the amount of energy use. It's also the source of many explicit and implicit fossil fuel tax expenditures, and the G20 in particular has recently committed to phasing out, I quote, inefficient fossil fuel subsidies. It's also an important source of government revenue in OECD countries. On average, 69% of environmentally related taxes are energy taxes. For context, this graph shows some major OECD economies and 4 of our partner economies, the percentage of environmentally related tax revenue to GDP, and you can see the brown colour there is the energy taxes as a percentage of GDP. For all countries, I think, but China in this graph, it forms at least half of their environmentally related tax revenues. The other taxes are tax on motor vehicles and smaller taxes. So the publication, as I said, provides the first systematic comparison across OECD countries. What it does is it takes tax rates that are applied to the consumption of energy, which are typically levied in monetary terms per litre, per kilogram, per gigajoule, and it converts them alternately into tax rates on energy content and tax rates on carbon emissions from that energy content. And for each OECD country, we provide a graphical profile of energy use and energy taxation, which I have a tendency to call them maps. So if I call them that, please bear with me. And we provide 2 of these for each OECD country, one in terms of energy and one in terms of carbon emissions from energy use. Having done this exercise for all OECD countries, we then had a fairly large database which we were able to draw on to do cross-OECD analysis. And so my presentation this evening is going to start by focusing on the graphical profiles and then turn to some of the cross-OECD results based on this work. So for the graphical profiles, the text-based information that we show is all energy use in a country for a year, and the year we use is 2009. And we divide this into 3 different macro categories. We divide it into transport energy, energy for heating and process use, and energy that is used to generate electricity. We show it on the horizontal axis of the profiles, and we convert it into alternately terajoules or thousands of tons of carbon emitted from energy use. Within each of these macro categories, we have a number of subcategories, and these are not consistent between countries. We differentiate these as required according to the different tax structures in each country. There are nonetheless some commonalities between countries. Gasoline and diesel for road use, for example, are common to all countries. For the tax rate information, we showed tax rates as at 1 April 2012, with the exception of Australia, where it's 1 July 2012. The difference was to capture the carbon price. And we include all taxes on the consumption of energy that are levied on a per unit basis, so taxes per kilogram, per litre, per gigajoule, per megawatt hour, etc. One tax that we don't include is VAT taxes, and we don't include other ad valorem taxes where these apply. We show in the profiles for each country the impact of the EU ETS and link this to energy tax systems as well. We show them on the vertical axis of the profiles, converted again to tax rates generally in local currency per ton of per gigajoule or per ton of carbon. Therefore, if you correlate the base size of each category with the tax rates, you have a rough estimate of revenue. So this is one of the graphical profiles. This is as it appears in the publication. This is the energy map for Korea. It's a little hard to read in presentation format, so I'll convert it to this. It just shows the same information. So on the horizontal axis, you have the total amount of energy used in Korea for 2009, which is just shy of 8 million terajoules. And we've divided it into the 3 categories. So transport is shown in the yellow colour. Heating and process energy is shown in blue right through to the edge of the red, and then fuels used to generate electricity are the red fuels onwards. So Korea uses 17% of energy for transport, for example, and that's relatively low relative to other OECD countries. 23% is the average across the OECD. And just over half of the energy in Korea is used for electricity generation. You can see the subcategories. The first 2 are gasoline for road use and diesel for road use respectively. And then in the heating and process sector, there's natural gas divided into residential natural gas use and natural gas used by industry, for example. And in the electricity sector, you can see the different energy mix used to generate electricity in Korea. On the vertical axis, we have tax rates that apply to each of these different fuels. And the revenue is there, the area of the bar is there for an estimate of revenue. Some quick observations about the tax rates. Transport sector faces the highest tax rates. This is something that we found to be common across the OECD. Heating and process use and electricity generation face lower tax rates. And they also are more frequently untaxed, or areas of them are more frequently untaxed than the transport sector. Another item that we show in the map is tax expenditures. And to do this, we draw on a sister publication, which is the Inventory of Estimated Support for Fossil Fuels, which you may be aware of. And this provides the first inventory of support to fossil fuels in OECD countries. And it includes tax expenditures, but also other forms of support, such as direct grants. But 2/3 of the measures in this publication are tax expenditures. Where these tax expenditures relate to energy, they're shown in the maps. And the tax expenditures that are reported in this publication and those that are shown in the maps are only those that are reported by member countries, so we make no judgments of our own on what constitutes a tax expenditure. What we actually show in the maps, therefore, is the benchmark rate that applies, that the tax expenditure was calculated against, the net tax rate, and the estimated revenue loss, again, the area of the bars on the maps. A few commonly reported tax expenditures that we note across the OECD are tax expenditures for agriculture, for fishing, for forestry, and often, it's not listed here, but domestic aviation as well. And there are often exemptions or reduced rates, or often rebates, for businesses. It's Putting these in context is often quite useful. You see how they fit within the broader scheme of energy tax systems in the OECD. When they're simply reported in an inventory style format, it's very hard to compare across the OECD because the benchmark rate may differ depending on the underlying tax system, and the choice of what is and isn't reported is vastly different between OECD countries. So putting them in context is very helpful in analysing tax expenditures across the OECD. And there are also implicit tax expenditures, kind of holes in the map, so to speak, that aren't listed as tax expenditures by member countries. So this is the energy map for the United Kingdom. And so again, we have all energy use in the United Kingdom along the horizontal axis and tax rates on the vertical axis. And some of the observations that we made for the map for Korea also hold true here. Transport is again taxed at considerably higher rates than energy for heating and process use or for electricity generation. But the differential here between gasoline and diesel, which I didn't draw your attention to in the previous map, is smaller than it is for Korea because they're taxed at the same rate in per litre terms. There are a couple of additional features on this map. I mentioned tax expenditures. There's a light grey area which might be a little hard to see just above the blue area there, and that is the rebate for the fuel duty for industrial and household users. And these are reported by the United Kingdom's government. There is a line going across some of the different categories here. That is the level of the climate change levy relative to the other taxes in the United Kingdom. I should mention this analysis was done prior to the introduction of the carbon price floor, so that is not included in this map. Another difference between this map and the previous map is that we have indicated the interaction with the EU ETS, and so we've indicated after the names of the subcategories with the letters A and P the sectors that are either almost entirely or partially subject to the EU ETS, but we haven't included the price signal impact of it on the maps. One feature I'll draw your attention to while we've got the map for the United Kingdom up is the difference in treatment of residential and non-residential users of energy in the United Kingdom. So in the centre of the heating and process column you can see the natural gas tax rates for industry and commerce, but residential users of natural gas don't pay taxes. Similarly, there's a lower tax on coal, I think, for residential use. LPG. This is the carbon map. So instead of showing the total amount of energy used by the United Kingdom for a year, we show total carbon emissions from energy use in the United Kingdom. And there's actually, often you get quite significant differences between the two maps depending on the carbon intensity of electricity. So countries that use coal expand the electricity section greatly, and countries with renewables it can practically disappear. And again in this we have the tax rate in terms of carbon on the vertical axis. And the difference here between diesel and gasoline, for example, has become larger due to the increased carbon intensity of diesel relative to gasoline. Having compiled these two maps for each OECD country, we did at the same time construct a highly differentiated database of energy use and energy taxes across the OECD. So for 65 different types of fuel and for around 35 different types of users, we can identify how much energy they used and the rate at which they were taxed for all OECD countries, which enabled us to do some cross-OECD analysis of effective tax rates on energy across almost any base you can imagine. So some of the main areas we analysed, we started with the base, the use of energy and carbon emissions from energy in the OECD. We looked at effective tax rates on a range of bases, on an economy-wide basis, so across all energy use in a particular country. We looked at the three major user groups that we identified in the maps, and then we looked at subgroups of users and at particular fuels within those groups. We also used the information in the maps to provide a quick snapshot of energy taxation in each country. And finally, we have had a look at the carbon intensity of economies and the overall effect of tax rates on carbon to see if there are any linkages there. And so for the rest of my presentation, I'm going to focus on the effective tax rate analysis and come very quickly to the carbon intensity analysis at the end. So this graph, which should be read against the left-hand scale, shows tax rates on energy on an economy-wide basis for each OECD country. So they range from 6.58 in Luxembourg to, don't quote me, I think it's 0.18% in Mexico. Yes, it's 0.18 euros per gigajoule in Mexico. The OECD simple average right in the middle there is 3.28 euros per gigajoule. The country with the highest effective tax rate on an economy-wide basis is Luxembourg. And the reason for this is that Luxembourg, as mentioned, the OECD average use of energy for transport was around 23%. Luxembourg uses roughly 65% of its of its energy for transport due to fuel tourism. And because transport tax rates are higher on average than other tax rates, this brings up their average quite considerably. The OECD weighted average is a lot lower than the simple average. That's OECD W down towards the right-hand side of the graph. And that's due to the presence of large economies at the lower end of the scale, particularly the United States, Canada, Australia, and Korea, which bring the weighted average down. If you look at the ordering of countries, perhaps it's easier to see on this graph, which shows the carbon tax rates on energy and should be read on the right-hand scale. The countries with the highest tax rates, particularly in carbon terms, tend to be European countries, and within European countries, Scandinavian countries. European countries, of course, tax energy within the framework provided by the EU Energy Tax Directive, which means that more heating and process fuels are taxed at higher rates generally than the Americas and the Asia-Pacific region, which tend to be represented down to the right-hand side of the graph. And the differences here in tax rates and in the ordering, where Switzerland is now first, followed by Luxembourg and Norway, who are pretty much even on this basis, is due to the different carbon intensities of the economies. So the countries where the rates have gone up considerably relative to their previous ranking tend to be those with high shares of renewables in electricity generation. The OECD simple average in carbon terms is 52 euros per tonne of carbon emitted from energy, and the weighted average again is lower at 27.1 euros per tonne of carbon. Looking more in detail at the categories identified in the map, we see that as was seen in the case for Korea and for the United Kingdom, taxes on transport energy are considerably higher. It's considerably more likely to be taxed, and they're considerably higher in almost all OECD countries than energy used in heating and process use and electricity generation. In several countries, heating and process use and electricity generation may be entirely free from tax, at least at the federal level. Also, within each of these categories, there are differences in how different users of energy and how different types of energy are taxed, whether that's the different fuels that are used or the different sectors using those fuels. This shows the average rate of tax on the different sectors in both energy terms and carbon terms across the OECD. The key message from this is that transport bears a tax rate in energy terms that's roughly 12 times higher than energy that is used in heating and process use or electricity generation on a simple average basis. So in transport, as I mentioned, it is much more commonly taxed and it's likely to be taxed at higher rates. Road fuels are taxed at higher rates than non-road fuels. In fact, if you look at the previous graph and previous table and divide this into road fuels and non-road fuels are taxed much more in line with the heating and process fuels and electricity fuels, but roughly 90 to 95% of energy for transport is for road transport, so it doesn't really impact the averages. And there may be reasons why road fuels faced higher tax rates. There may be other externalities that are being addressed through the tax system, for example, accidents, congestion and noise, although there are more direct ways to address these externalities than road fuel taxes. But another reason that we get feedback from our member countries is quite simply for revenue raising purposes. For historical reasons, road fuels are taxed at higher rates. One common theme across all the sectors is that oil products face higher tax rates than coal, natural gas, renewables and combustibles. But within this, there's a consistent difference across OECD countries, and that is that diesel is taxed at lower rates than gasoline. I'll come back to that point. There are some common exemptions that we note within this sector. There's generally a lower rate or exemption for domestic aviation. We don't include international aviation in the maps. There are often reduced rates for rail and marine transport, and in some cases there are rebates for heavy transport as well. Where there are explicit CO2 taxes in this sector, which tends to be in the Scandinavian countries, they form a very small proportion of the total tax rate that's levied on road transport as well. Now, this graph shows the tax rates in terms of energy on gasoline and diesel in each OECD country. Before I look at this, there are four OECD countries that actually tax diesel and gasoline at least the same rate per litre. So the United Kingdom and Australia tax it at the same rate per litre. Switzerland has a very slightly higher tax rate in litre terms on diesel than it does on gasoline. But the higher energy intensity of diesel relative to gasoline means that when you convert it into tax rates based on energy content, every OECD country except the United States, which is second from the right, taxes gasoline more heavily than diesel. And it also, in addition to having a higher energy intensity than gasoline, it also has higher carbon emissions associated with either a litre of diesel or a gigajoule of diesel. So on a carbon basis, these gaps get slightly larger. And it's still, the US is still the only country that taxes it at above the gasoline rate. New Zealand and Finland in particular would like me to mention that they do have increased tax rates on diesel vehicles relative to gasoline vehicles. But I would argue that in terms of incentives at the pump and incentives to drive further, this doesn't really give you any incentive to reduce your driving. One thing to note with this is that the OECD simple average is 32% lower for diesel than it is for gasoline, but if you look at the weighted average, which was 4 from the right-hand side, you'll see that the tax rate on diesel is actually higher on a weighted average basis than the tax rate on gasoline, which is also somewhat counterintuitive until you look into it and realize that the United States by itself used 65% of the gasoline in the OECD, but only 38% of the diesel. And so it drags the gasoline rate down considerably more than it does the diesel rate, and you end up with this result. We can correlate the amount of diesel taxation relative to gasoline taxation against the amount of diesel used relative to gasoline. So on this graph, on the horizontal axis, we show the amount of diesel used relative to the amount of gasoline used in each country. The 100% mark on the horizontal axis therefore would show a position where they use identical amounts of gasoline and diesel. Anything to the right of that axis shows a situation where countries use more diesel than gasoline. Anything to the left, the inverse. Similarly, with the vertical axis, the 100% mark shows a situation where countries tax gasoline and diesel, and this time we've shown it in energy terms, at the same rate. And so the only country above that is the United States. All the other countries tax it less. And at least on a simple scatter plot, there appears to be a correlation between the amount, the tax preference for diesel and the amount of diesel used relative to gasoline. The outlier on the far side there is Belgium, which uses more than 5 times as much diesel as it does gasoline. And New Zealand is down the bottom with no tax in diesel at the pump. On a purely static estimate, if the tax rates on diesel were raised to the level of tax rates on gasoline in gigajoule terms, this presents revenue estimates for OECD countries. And I'll emphasize this is purely static. We haven't looked into behavioral impacts of this, but in total the estimate would be 56 billion euros across the OECD if tax rates on diesel were raised to the same level in energy terms, and higher if they were raised to the same level in carbon terms. And this graph shows the proportion of revenue that is missing under that analysis for each country, and the numbers in white there show the revenue estimates for each country. Moving on to the heating and process fuel sector, as I mentioned, it's almost always taxed at lower rates, considerably lower rates than transport. But within this sector, different fuels face very different signals. So oil is taxed again most heavily. Coal and natural gas are taxed at much lower rates than oil products. There are also within OECD countries differences in how industrial users and residential users of energy are taxed. And there's no clear pattern here. I've mentioned here that 16 OECD countries tax industrial use more heavily than residential use. 11 tax more lightly. 11 countries go the other way around, including the United Kingdom, and the other countries were too close to call. So this may be due to competitiveness concerns, it may be due to distributional concerns, in some cases expressly so, in other cases we are not sure of the reasons for this. But the message from this publication, from previous OECD publications, is that these concerns can typically be targeted in ways that don't reduce the price signal sent by energy taxes. One thing to be aware of with the analysis for this sector in particular is, as I mentioned, the EU ETS is shown, but the price signal isn't included. However, in 2012, the price signal provided by the EU ETS was fairly modest, between 6 and 9 euros per tonne of carbon. This shows tax rates on certain fuels in the heating and process sector only. I haven't included all fuels, but there's a comprehensive table in the publication, and also on a per country basis as well as across the OECD. And it shows simple average tax rates on diesel, fuel oil, natural gas and coal. Oil products are taxed at higher rates, as I mentioned. Natural gas and coal across the OECD on average are taxed at lower rates, but roughly the same. But because coal is significantly more carbon intensive than natural gas, the tax rates when converted to effective tax rates in terms of carbon are much lower for coal than they are for natural gas. This doesn't give you a whole lot of information about the distribution within the heating and process sector. And to be honest, when we tried to look at this, often you'll find that the lower quartile median and sometimes the upper quartile is 0 if you do it on a cross OECD basis. As I'll show you in this graph, what we've taken here is all energy from 3 fuels, from coal, natural gas and oil, within the heating and process sector across the entire OECD. And we've ranked them from the lowest taxed to the highest taxed, from 0% of that fuel to 100% of that fuel. So this is the curve for coal. 65% of coal is untaxed in the OECD, and almost all of it is taxed less than 10 euros per tonne of carbon. This graph is on a logarithmic scale just to emphasize the differences at the bottom. Natural gas is actually more natural gas is untaxed, but where it is taxed, it does tend to be taxed at higher rates, and considerably more natural gas is taxed at more than 10 euros per tonne of carbon. And oil is more commonly taxed within the sector and taxed at consistently higher rates than either of the other 2 fuels. If you look at the weighted means for each of these different fuels, the weighted mean is 2.58 for coal, it's 5.14 for natural gas, and 11.77 for oil. The maximum tax rates, which are quite hard to read off this graph, also differ considerably. Oil is around 328 at the top, and coal is just over 120. Moving into electricity generation, there are 2 ways that OECD countries tend to tax electricity. The most common is to tax the consumption of electricity. This is what's provided under the EU Energy Tax Directive. But some countries also tax the generation of electricity, and some countries do both. For the analysis, we looked through the consumption of electricity to the fuels underlying that consumption. So we treated taxes on the consumption of electricity as implicit taxes on the fuel mix used to generate that electricity. However, the fuel mix used to generate electricity is more diverse than in any of the other sectors, which means that the carbon tax rates on electricity vary very considerably across OECD countries. The key message from this is that taxes on the consumption of electricity may provide incentives to conserve electricity, but they don't provide any signal to the underlying fuel mix used to generate electricity in member countries. This just shows a simple table of how the land lies essentially for electricity taxation. 17 countries tax only the consumption of electricity. 5 countries tax neither electricity generation nor electricity consumption, and several countries do both. This graph shows the mix of different fuels across the OECD in energy terms used to generate electricity. And I've loosely ranked it in order from the most carbon intensive, loosely, to the least carbon intensive. So the dark brown colour is coal, the reddish colour is oil used to generate electricity, the orange is natural gas, the darker grey colour is combustibles and waste, which tends to be primarily wood products, the light grey is nuclear energy, dark blue are the renewables, and that includes biofuels, although they're quite small, also wind. The large areas of light blue for Iceland and for New Zealand are geothermal. And dark blue shows hydroelectricity. And you can see there's immense differences in the renewable content of electricity in the OECD, from Israel, which uses exclusively fossil fuels to generate electricity, to Iceland, where almost all, there's a very tiny bit of oil in Iceland, but almost all of it is renewable. Another thing that jumped out at me when I did this was Luxembourg, who have a heavy reliance on natural gas for electricity mix. 3 countries, Estonia, Poland and Australia, primarily use coal for their electricity production. Using the information in the maps, I mentioned we can provide snapshots of energy taxation. So this follows a similar pattern to the earlier graph, where we take all energy in a particular country, measured in carbon emissions from energy, and rank it from the lowest to the highest tax rate in each country. So this is the energy snapshot of taxation for the United States. They don't tax about 67% of energy in carbon terms, and the remainder is taxed at fairly low rates. The two big categories there are gasoline and diesel. The very last small bit is biofuels in the United States. If we compare that against Australia, slightly more energy is untaxed, but most energy is taxed at higher rates. Again, the top ones are transport forms of energy, gasoline, although they have reduced rates for heavy transport in Australia, which makes it a little less clear. This shows France. I mentioned European countries typically tax fuels more heavily. So France taxes a substantial amount of its carbon emissions from energy use and applies higher rates. This is the United Kingdom. Higher rates again than France. And the highest rates are observed in the Nordic countries and Scandinavian countries. I've included Norway. I could have equally put Sweden or Denmark, which shows similar profiles of energy taxation across the whole economy. One interesting find we made was that if you look at units of GDP on a PPP equivalized basis, the carbon intensity of GDP and the level of carbon taxes in a country, there appears to be a relationship between them, with economies that are relatively more carbon intensive facing, on average, lower carbon tax rates. So again, we need to be cautious about drawing correlation from a scatter plot, but nonetheless it was interesting, and there's a range of possible reasons that could explain it. One would be that higher prices on carbon through the energy tax system provide incentives either to use less carbon intensive sources of energy or to be more energy efficient. On the other hand, it could be a chicken and egg type situation where countries that have energy intensive means of production face greater barriers to introducing taxes on carbon. So I've identified a few countries there, including the United Kingdom. Switzerland at the top. The next plus just down from Switzerland is Norway, and the rest of the countries are identified there. Well, conclusions across the OECD. As you've seen, effective tax rates on energy vary quite widely across different sectors, across different fuels and within different sectors, which means that many sectors don't face an adequate price signal in terms of their energy use and their carbon emissions. Often the differences appear to have arisen from historical accident or incomplete consideration. And some of the common ones that we've noted include the difference between diesel and gasoline, the tax exemptions that are common in many sectors, including for agriculture and occasionally for mining, the different fuels within heating and process generation, also within electricity generation, face very different price signals, and that low rates may be driven by competitiveness and distributional concerns as well. Policy implications for this, for the OECD, is that the signals sent by energy tax systems within the OECD are often uncoordinated and unclear, and energy taxes should be considered in conjunction with other policy measures which could be used to better address some externalities or to address some of the concerns arising from the imposition of energy tax systems in such a way that you don't mute the price signals that are sent by energy taxes. The main message for OECD countries from the work is that in general a reappraisal of energy tax systems is warranted to ensure that they meet their environmental, distributional and fiscal goals. Thank you.